Welcome. Today we're going to talk about the business value of continuous integration, continuous delivery, and DevOps with application security. More importantly, how to scale up your product and service delivery lifecycle to multi-billion user global systems of systems using containerized microservices. Feel free to visit my website where you can get this brief, my Lean and Agile videos, as well as all of my white papers on how to apply these concepts to complex systems. I've been a U.S. government contractor for nearly 4 decades. My background is in computer science and information systems. I'm a career systems and software engineering methodologist. My first project was NASA's space station. I published the first books on the ROI of traditional as well as agile methods. By now, most of us have heard of the Internet of Things, which is a dinosaur killer or extinction level event. There are tens of billions of devices and Internet hosts, soon to be trillions with billions of phones, and most .coms have billions of end users, placing enormous pressures on today's Fortune 500 firms, making this a legitimate extinction level event. DevOps has emerged as an answer to help prevent this extinction level event, based on principles of early, iterative, and automated development and even cloud operations, based on principles of lean thinking, product development flow, and even agile methods, based on collaboration, teamwork, iterative development, and responding to change. It's really a family of related techniques that, when used together, help improve business value, success, and even resiliency. So how does DevOps work? Well, in the DevOps paradigm, requirements are implemented in slices versus layers. Rather than implement overscope systems using traditional methods, fewer higher value requirements are implemented first, one at a time. And when you do this, it speeds up the delivery lifecycle, increases business value, but more importantly, it reduces risks, defects, performance bottlenecks, as well as security vulnerabilities. At its heart, DevOps is truly a modern lean and agile practice based on principles of one-piece workflow. Therefore, we can use cumulative workflow diagrams to illustrate the effects of applying DevOps principles and practices. When your batch sizes or number of requirements are too long, this obviously elongates cycle times and lead times and reduces quality. But when you use DevOps practices to reduce batch sizes and numbers of requirements, using feature slices, you actually decrease lead times and cycle times and increase quality dramatically. Over the last 20 years, a family of techniques has emerged to help us reduce the risk and increase the success of product and service delivery, such as minimum marketable features, minimum viable products, and even minimum viable architectures, which, when we reduce the scope, the cost, the risk, the size, it increases testability, quality, reliability, security, even team morale, system maintainability, and ultimately success. The secret sauce to the information technology revolution is clearly the notion of microservices, which are small autonomous services. Rather than building over-scoped applications using traditional paradigm, we build much smaller applications and we tightly wrap them in containers replete with the image, the middleware, and just enough operating systems. We test them and we secure them and we deploy them to billions of devices in fractions of a second. Of course, the best approach is to begin engineering a bottom-up, lean and agile microservices-based architecture from the get-go. However, global enterprises have 80 to 90% of their IT budgets wrapped up in legacy systems from the 1960s and 1970s. So more and more guidance is emerging to help these traditional organizations decompose their legacy systems using domain-driven design and service-based architecture so they can evolve to a microservices-based architecture. Of course, the best idea is to create one, from the very beginning. The DevOps revolution didn't happen overnight. It's rather an evolution of closely related concepts like lean and agile methods, concepts like test-driven development, continuous integration, behavior-driven development, continuous delivery, DevOps, and even application security and microservices.
Once again, this revolution or evolution started with agile practices like test-driven development, where small extreme programming teams pulled user stories off the backlog one at a time in one-piece workflow. They first wrote their tests, then they ran the tests, then they wrote the code, and then they reran the test and refactored the code, working out the waste, and then tested it and delivered it to the end users as quickly as possible. This slide illustrates the basic test-driven development concepts. Take the user story off the backlog one at a time as a small pair programming team. Clarify it, understand it, split it, right-size it, write the acceptance criteria, develop the tests, run the test, write the code, rerun the test, and then refine the code to its smallest waste-free state. Another closely related practice is the notion of behavior-driven development, whereas TDD focused on rapidly coding and testing user stories or software units one at a time. Dan North realized the necessity to write tests and for larger groups of user stories called features, and this is a less frequent process, so TDD cycled faster while BDD cycled a little less frequently. The BDD process is very, very similar to the TDD process, except that you look at the feature statements one at a time, you try to understand them, you write the acceptance criteria for the features, you develop the feature tests, you run the feature tests when groups of user stories are complete, and you continue refining those features and refactoring until larger groups of user stories function or satisfy your tests. Beyond the advent of lean and agile methods and practices like extreme programming and Scrum, TDD, and BDD, the next major evolution or revolution in this saga was clearly the advent of continuous integration. As programmers pulled those user stories and features off the backlog, wrote those tests, and that they checked them into the version control server where millions of tests were automatically run, kicking back the erroneous code back to the developers for further refinement, or if the tests passed, they were actually installed on local hosts or delivered for further independent testing. Let's examine some of these continuous integration practices that are very, very controversial even today, 20 or 30 years later. We have the automatic building and integration of the code, the building of the databases, the automatic static analysis, the automatic testing, the automatic feedback to both developers and users and project managers, even automatic document generation and automatic deployment. So far, we've talked about the evolutionary or revolutionary practices like lean and agile methods, Scrum, extreme programming, TDD, BDD, CI, but a small variation of this is continuous delivery, whereas continuous integration focused on test automation, continuous delivery focused on the final packaging of the product for independent testers or delivery to end users, historically representing 80% of the development cost. Let's quickly examine some of the value-adding practices of the continuous delivery paradigm, the packaging of the software or the system for final delivery, any automated acceptance testing, load testing, performance testing, any pre-production testing, any certification testing, and any pre-deployment testing if necessary. Once again, very controversial, somewhat subtle, and reduces a lot of cost and defects. Clearly, the next major revolution in this saga was the advent of development operations or DevOps, which recognizes the existence of the development organization as well as the IT operations organization and the collaboration necessary to develop and deliver the product to the end user. So everything we've talked about so far focused on the development community. Now, DevOps really kind of focuses on what the operations community has to do. Let's examine some major DevOps activities like system administration, configuration management of assets, host builds, virtualization, containerization, deployment, monitoring, and support. When you can standardize, simplify, debug, automate, and even push some of this back into the development stream, then you can reduce your costs and increase your speeds by orders of magnitude and deliver your Microsoft services to billions of global end users in fractions of a second. As we've painfully discovered over the last 2 or 3 decades, when you deploy your IT assets to billions of global users, security becomes a major issue. Thus, DevOps security comes front and center, which is a triad of security engineering, secure microservices, and secure operations. That is, you must engineer your assets to be secure from the inside. You must secure your containers to internal and external penetration. And of course, you must monitor your global IT assets. So let's look at some basic DevOps security practices, such as engineering the applications in a secure way. That is, you must bake in your security, not ice it on the end. You must have secure containers. You must evaluate those containers. You must deploy them in a secure way. You must protect them while they're deployed. You must monitor them, and you must provide an adequate security response.
Edward Pound, author of Factory Physics for Managers, astutely observed that it's not enough to have lean and agile practices such as one-piece workflow. One must wrap their DevOps pipeline in a tightly integrated framework of business agility, portfolio operations, large solution engineering, and even program and project management. The Scaled Agile framework is one such model that's evolved in order to do so.
Software development automation has always been viewed as somewhat of a silver bullet since the software factories of the 1970s and the case tools of the 1980s. But we've talked a lot about automation, so let's examine some of the tools within the DevOps ecosystem. Obviously, there are tools for computer programming and committing, building and configuring, scanning and testing, and even doing release and deployment.
Today's DevOps ecosystems have become unnecessarily complex in the 21st century. Xenia Labs has done a very nice job of developing this DevOps periodic table to classify those tools into source control management, database automation, CI testing, configuration management, and so much more. Modern cloud services providers such as Amazon are starting to untangle this mess once and for all.
We've also talked a lot about DevOps security, so let's examine some of these security tools. That is the basic ones. Obviously, there are basic security tools for the coding process, the configuration management process, and storage and building and integration, as well as deployment. Much like the Xenia Labs periodic table of DevOps tools, the SANS Institute has also constructed a secure DevOps toolchain with security analysis tools for the pre-commit stage, for the commit or continuous integration stage, the acceptance or continuous delivery stage, the production or continuous deployment, and operations. Definitely Google the SANS Secure DevOps Toolchain poster. It's free on the internet. Let's examine some basic DevOps metrics. Obviously, test coverage becomes very, very important. Over 70% of code is dead code or unreachable, so test coverage will tell you how much of it has been tested. Obviously, test automation becomes key to increasing test coverage, and obviously you want to increase your number of integrations and builds because this drives down defects and solves problems earlier. But when you combine all of this coverage and automation and integrations, it actually increases your delivery speed.
Well, the previous slide focused on internal or white box DevOps metrics. This slide focuses on external black box metrics such as deployment frequency, change volume, lead time to deployment, failed deployments, mean time to recover, customer ticket volume, which are extremely important, and the US DoD has recently completed a study on DevOps metrics.
The DevOps Research or DORA group does some very, very sophisticated organizational DevOps assessments, and they measure your team's performance in terms of IT performance, your lead time, your deployment frequency, your mean time to failure, your change failure rate, your even morale metrics like your burnout rate and your deployment pain as well. Remember, as we said before, traditional teams, over 80 to 90% of their development costs are in manual operations. But when you deploy and employ lean and agile practices, including DevOps practices, you flip the cost of quality upside down, increasing your return on investment by thousands of times. That is, the cost of developing and actually verifying and validating becomes fractional so that you can actually deploy your assets thousands of times faster. This is a real-world DevOps case study by Hewlett-Packard where they reduced their build times, increased the number of their builds, reduced their feedback cycles and their testing costs, fractionalized their development costs, freeing up 80% of the resources for new products and services, innovation, and return on investment and revenues. There are actually 3 .com DevOps studies on this slide, one by Assembler where they increase the number of their deployments from 5 to about 50, which is where Facebook is. Google runs about 120 million tests per day on their entire product line, and Amazon does nearly 136,000 releases a day to their baseline. Remember, the average length of a U.S. government project is about 8 to 12 years, so this is literally thousands of times faster. This is a fascinating Blackboard case study where they were integrating their code into one massive ball of yarn, and their productivity actually dropped to 0, and their quality actually got worse. But once they sort of broke up their architecture into microservices, once again their productivity took off, but so did their innovation as they freed up their development resources to focus on new higher value adding products and services, as well as reducing operational costs and increasing profits and revenues. This is a fascinating DHS DevOps case study where they continuously refactored their development lifecycle over a short period of time to reduce the release time, reduce their documentation, reduce their gate reviews to achieve world-class performance where traditional teams want to slow the process down, increase their documentation, and increase their gate reviews, which actually worsens quality.
Tesla is just one of many emerging hardware-intensive industries and technologies in the 21st century that's integrating DevOps principles and practices into its platforms. They have nearly 200 million lines of code and do over 130 deployments per day, and are dispelling the myth that lean, agile, and DevOps practices cannot be included in safety-critical systems. About a decade ago, it was once believed that only the top 2 or 3 .coms could apply DevOps principles at scale, but today nearly all online retailers are applying DevOps principles. Google does 150 million tests per day. Netflix uses DevOps to achieve 0 downtime. Obviously, Amazon does 136,000 deploys per day, and so on. This is still a late-breaking study by DevOps Research illustrating that medium-sized firms can immediately get $66 million in benefits on $1.3 million in cost to achieve a 5,000% ROI in only about a week. DevOps adoption was just a little bit slow over the last 10 to 20 years. However, today 74% of global firms are now using basic DevOps principles and practices, which are now being subsumed by other types of technologies such as cloud computing, Amazon, and even the AI phenomenon.
Here's a simple but effective DevOps implementation roadmap, and it suggests that organizations and projects should focus on simple build and integration tools and processes, move into the heavier duty testing processes, and finally into the more sophisticated automation and deployment and security monitoring process. Of course, all of this assumes you have a strong foundation of lean and agile practices.
As we've suggested throughout this video, DevOps has crossed the chasm from the early adopters to the early majority. And the future of DevOps is really in increasing better DevOps experience, BI DevOps, and even AI Ops. Here are some simple, critically important, but powerful keys to DevOps success. Obviously, everything begins with lean and agile principles. You must downsize your portfolio because you simply can't build everything on the planet no matter how much money you have. You must simplify your architectures and designs, use modular interfaces and microservices, complete end-to-end automation, but most importantly, everything begins and ends with leadership at all levels. DevOps clearly does not mean to deliver it now and fix it later, as our pundits would have us believe. It's a lightweight yet highly disciplined approach to new product and service development to reduce cost, risk, waste while improving quality. You must involve your customers early, scope complex portfolios and programs by an order of magnitude, divide your remaining scope into smaller batches, implement your microservices in small cross-functional two-pizza teams, and incrementally test your experiments as you go along to uncover tacit knowledge. So what's the bottom line on DevOps? Well, DevOps ensures enterprise success by helping your organization deliver large volumes of valuable, reliable, and secure IT products and services to billions of global end users in fractions of a second, just like the major .coms, Apple, Yahoo, Amazon, so forth and so on. Using DevOps, it will certainly help you avoid the extinction level event of the Internet of Things. Thank you for listening to this DevOps video. Please visit my website, davidfrico.com, to grab my briefings, YouTube videos, and other white papers on DevOps and other lean and agile principles and practices.